description of point operators as six segments with an analogy. So let us start. So assume you are a baker, okay? You are going to make a cake. So you will have a bake sheet and you will have different pieces of cake, right? You will have different pieces of cake. Okay. If you want to add a decoration to one cake, you will do it one time, right? So if you want to make decoration in another cake, you will do it next time and then the next one and then the next one. Similarly, it will go on. So consider this as a image. So each image will be considered as a collection of pixels. Okay, so when we apply any brightness or contrast, the every pixel will be changed. So that is what represented as point operators. A basic image processing tool that adjusts things like brightness, contrast, color without considering the neighbor pixels. Only one point at a time will be considered. So if you are decorating a cake, you will focus only on the current cake. You won't focus about the neighboring one, right? So similarly, if you want to adjust the brightness of an entire image, we'll focus on pixel by pixel. We won't consider the neighboring pixel. This process is called point operator or also known as point process. The pixel transform is similar to the analogy we have seen earlier. So, yeah, same. So, if I want to transform the cake, if I want to add some toppings in the cake, means I'll perform in one cake and then I'll go on to the next one. Similarly, pixel transformation is mapping of input pixel into output pixel. If I want to change the red color, if I want to enhance the brightness of the red color, means I will perform the enhancement. So that will be converted into one color to the another color. So the general mathematical function that map the input image into the input pixel into the output pixel is known as pixel transforms. It can work in both grayscale image as well as the color image. So the next one is color transformation. Give me a minute. So the next one is color transformation. In color transformation, okay, let us take a piece of cake. Okay, if I want to add few more layers, okay, so I may want to add a blueberry or I may want to add a green pistachio layer. So I will perform layer. I'll add some layers, right? Okay, on applying these additional layers, taste may also be changed. The taste may also be changed. So the advanced bakers, what they will do means they will perform some icing or they'll add some more syrup and then they will add those additional blueberry or pistachio. The color or the taste won't be changed. So similar analogy applied in color transformation. Here the color transformation will work on the RGB. So the previous pixel transformation can work on both grayscale as well as colored images. And the color transformation works on RGB, so it is a three color channel RGB. Okay, so whenever you hear a name three channel, it represents red, green, and blue. So here we have represented additional of layers like blueberry, pistachio. Here I am going to add brightness. Means brightness will also add some constant value to each channel, but it also affects the hue and saturation. Here we said that, right? So adding few more layers in the cake may change the taste. So adding a brightness or contrast, it may also affect the hue and saturation of an images. So what we have done, more advanced bakers will apply syrup or icing and then they will add the layers which won't affect the taste. So similarly, more advanced method like conversion of X, Y, Z space or using 3 cross 3 transformation images won't change the original color. It may balance the white color or it may perform the color selections. The next one is image mating and composition. So assume you have a tray of cakes. If I want to change the cake into one tray to another tray means I have to first pick up the cake and then I have to transfer into the new plate. In while plating the cake in the new plate, it should not be damaged. It should be settled correctly. So this process can be converted or mapped to matting and composing. Image matting means extracting only the foregrounding object. Okay, compositing means placing that foreground onto the new background. Okay, so we might have done some kind of editing. We'll extract only the background, or we'll remove the background. So extracting only the foreground image is known as matting, and placing that foreground onto the new background is known as compositing. So while placing that onto the new plate, it should not be broken. So we can apply some kind of syrup or icing that is known as pre-multiplied alpha here. Okay, so it will be suitable for better blending and transformation. So the next one is histogram equalization. Histogram equalization means, so whenever if you want to apply some chocolates, okay, so look at this tray. So this column may have more chocolates and this column may have less chocolates. So I want to distribute all the chocolates equally. So what I may do, either I'll remove some chocolates from this part and I'll add here, or I'll add more chocolates in this one, okay, to make it equalized. This is known as histogram equalization. Okay, it will enhance the image contrast by redistributing the pixel intensities, so which will make the image look normalized with all the colors. So two methods are there. First method will map the darkest pixel to black and brightest pixel to white, which will make the photo more color balanced one, or else it will use average pixel value. So instead of taking darkest as well as brightest, it will take the common average value and stretch it toward a middle gray. So because combination of extreme bright and extreme dark is known as white and black, and taking average will get a middle gray. Okay, either we'll add a black or white to the extreme values, or generally we'll apply the middle values to all the pixels. So it can be a global or local, which means I can apply this gray color to entire whole image, or I can apply the gray color only to the part of the image. So that is represented as global or local. And few methods used for histogram equalization are adaptive histogram equalization and contrast limited adaptive histogram equalization. And few more applications are tonal adjustment for better visual appeal, and it is common in photo editing software like adjusting contrast, brightness and color balance. So as a chef, we have added a syrup, we have added a layer, we have moved the cake from one to another place, and we have placed this on topping, right? So similarly, as a photographic editor, we will perform brightness, contrast as well as color balance. So while performing all these operations, it will take place by pixels, and it can also be applicable for colored image as well as grayscale images. So that's what represented here. This is very brief intro about point operators. Thank you.